Yes. We won't go too long today. For a couple of reasons, it's not much to go over. So if you're signing up for labs, I'm not sure if you've seen the message, but round 2 is up and it's going to close at noon tomorrow. But I would recommend taking some time out today to try to formulate the teams and make your decision on which project you're going to be on. So I wouldn't wait to the last minute, but it closes at noon tomorrow. So let's see here. So how did the cash go for you guys? How did it go implementing something? Was it easier than expected, harder than expected? Cool. So there. Put that there. Like this one. Yeah. Thought it wasn't too bad. Nice to understand the concept better now. Awesome. Cool, cool, cool. Hopefully everybody felt that way. Awesome. So let's get started with this here. I'm gonna go over a few functions, but not actually do everything because some of you may be still working on some of this. But another reason why we would not have so much to go over today and have a shorter lecture is because I think it's important for you to go into the sprint tomorrow with something to reference in full. So have everything completed so that you can move forward with the sprint tomorrow. The sprint will be a lot similar to what you've been doing this week. So because it's going to be a lot similar, I think that having the MVP for the week done is just going to help you. That way, if you run into any issues on the sprints, you can reference parts of your code from this week. So it's not going to be exactly the same on the sprint, but there will be some similarities that you can work with. And do not disturb on the phone. All right, good deal. Right. So yesterday we talked about kind of how we could start this project and how we would skim over it and what we can do. So we're kind of going to do that a little bit more today as well. And then we'll go over some solution here. So that's not what I'm looking for. Web server. I'm looking for the README. Okay, let's go back one more. Cool. So I didn't mention this part yesterday, so I want to go over it real quick. Let me share my screen. Let's share screen 2. And hopefully everyone's looking at the README right now.
Yep.
So, thanks. So we can go over and we can see the README actually had some pretty good pseudocode for cache puts, giving you steps of what to take. We kind of just looked at the inside of the repo yesterday, and then we had a Python implementation. What's on the README, there's some algorithms and some steps to take to getting things to work. So hopefully you got a chance to read that. If you haven't, I'm pointing it out to you right now. So this could be very helpful if you actually follow these steps one by one. So we had this to skim over to use to attack the problem, and as well attack the problem today, as some of you may have not completed MVP totally for the week. And that's fine. That's what we have the rest of the day for. But this is where I would go to in order to take a look at what I need to do. So if you're asking questions, hey, how do I implement this thing? This part of it, I think, was the most in-depth as far as the steps to take. And so it should answer a lot of your questions. Now, if there's something that you don't understand, then once again, use the resources and contact a PM and see what we can come up with together. If you have reached the MVP, there are a few different stretch goals we can implement. Being able to post, which is not that much code actually. You've done the bulk of the work, so I would recommend stretching, making it look as great as possible. You can add endpoints. It's a few things that you can do that's not even listed here. You can add endpoints, maybe actually create a website with one of your index.html. It's kind of dull right now, but we can make that look a little bit better, and maybe design something that looks a little bit better so that you hit that endpoint. And maybe this is something that you want to add as a portfolio piece. And I think right now, just hitting MVP, it's impressive that you got through it, but it could look a lot better, and that would make it something that you might want to add to your portfolio piece. So there's a lot of things that you can do to kind of make it more impressive. We can do cache entries, expired cache entries, and we'll talk about this a little bit after I go over the solution, but that's another thing that you can do. So let's go into it. Let me pull up the file and let's take a look. So the first thing we're doing is we have to allocate the entry. So yesterday we talked about, I'll make this comment here, we're going to use malloc to some degree, right? So as we were skimming over, we kind of made the assumption that, okay, because we're allocating the entry, we're going to use malloc to some degree. And so there's a different way that you could have done it that I want to go over right quick in case you didn't use malloc, or you kind of considered the option where we won't use malloc. And I want to kind of talk about that a little bit. So what we could have done here is we could have, well, we're going to use malloc, but I guess we could have made a shallow copy. So let me show you what a shallow copy is here. So of course we know that we're going to need something to put everything in. So we make this struct pointer. We're going to malloc size of, and now at this point here, I could do this here, but this is shallow once again. And I don't actually want you to do it shallowly, but I want to show you this, kind of talk about it. The type will equal content type, CE content length equals content length, and CE the content equals content. Great. And I think that's maybe I'm doing something wrong here. Oh no, good. So this is kind of how we could have done this shallow copy. Can anybody tell me why this is a shallow copy, or what are some of the disadvantages of doing it this way? There's a more optimal approach, which I will show in just a second, but does anyone see anything wrong with this way? If the parameters given to the cache entry are changed later, the cache entry will change as well. Correct. That is correct, Andre. So that's one disadvantage to it. These could be deleted and then you wouldn't be referencing anything. That's correct. That's another disadvantage, Ian. So you're right. So we're making this shallow copy. So we're just kind of accepting what it is right now. And if those change later, it could change our entry. It can change our data. If for some reason that is deleted, now we have this entry that has nothing in it or points to garbage or something. So we don't want to do it this way, though in a very, very basic and minimum program, we may not have a problem, but it's kind of setting us up to later have problems. And so as we program, as we've learned, being that this is our last day of CS and we're going to labs next week, we should have some understanding that when we code or program something, we want to prevent problems that can occur down the road. So as we're programming, we kind of have to think about this. Hey, all right, I'm developing this thing or implementing this thing. What can go wrong later and how can I prevent it now? Okay. There's a big concept in programming where they say maintenance is expensive. And so we can prevent having to update this later if we kind of do it more optimal now. So what's the approach to actually making a deep copy of this thing here? What's the path? Let's work with the path first. So if I'm working with the path, I get access to the path with my arrow here. We're using the arrow once again because this is a struct pointer. So what does this line of code look like? Okay, very close, very close. So we have to malloc some type of size, right, or some type of length. So we couldn't just put path in there, but we would need the length of the path, right? Plus one. So what could we use to get the length of the path, Michael? Or if someone wants to help them out. Yes, Sterling. So we go Sterling plus one. Awesome. And that should go from, shouldn't be read anymore. Cool. And pop quiz, Sterling, what header file do we need to include in order to have access to Sterling? Does anybody remember that? Stream.h, yes, correct. So at this point, we've malloced our space. So here we allocated our space. what do we need to do to actually put the path string inside of here? And again, we're going to use this deep copy. So how will we be able to do this? What function? Copy path into the allocated space. Correct, Sean. That is the next step that we need to do. And I'm going to use what you just stated as my comment here. So what does this look like? What function could I use? Or could I just do this now that I've allocated the space? Could I do that? Or what function do I need to use? String copy, correct. So now we're going to get a copy of this thing. With mem copy would work, but we know that this is a string, so we can use string copy. But mem copy would work as well. We'll talk about that in a second there, though. So this is a part of the code that we definitely may want to consider using mem copy over string copy. Path. Cool. So now that we know what the path looks like, Michael, can you help me with the content type? Now we've got an idea. So it's going to look very similar, just kind of flip words. But can you help me with this content type? I need to allocate the space first. And I'm asking you because you tried the first time and then we had to make an adjustment. So I just want to make sure that you understand this next part. Okay, so there's an adjustment we made. So when we did this part here, you put path in there and we had to make this adjustment. So what do we need from the malloc? What should be inside of those parentheses with the adjustment we made on the first one? So this is actually doing our deep copy, by the way. The stir copy, that's going to do our deep copy. But how does the allocation of space look like for content type? Correct. Awesome. And we need that because if we take a look at malloc, it needs some type of size or some type of length in there. And so that's why we can't just put in content type. I'm pretty sure this is going to give me an error, but let me see if it does. It's not going to give me an error right now. But if I tried to run it, it would. But I was hoping it would give me something right then and there. But C doesn't work that friendly, I guess. And we need to do +1, or did I add too many parentheses here? Yeah, I think that I don't. Cool. Cool. And so now we can, no, that's stirred len. No, that's not. I don't know why does it keep doing that? All right, cool. All right, good. All right, so stir, copy, and then we're just gonna do the same thing there. Content type. We're gonna put our content type in here, and that is taken care of. Now let's work with the length. So with content length, what do we need to do with this? Are we going to have to malloc space? And if we don't have the malloc space, why not? It's an int, so we don't need to. Okay, correct. In a nutshell, that is exactly we don't need to. So we can kind of do what we did up here. And we're not going to have any problems at all. It doesn't matter what happens later. It's automatically going to give us kind of a deep copy, so it's going to be just fine. And great. So let us do the content. Let's take care of content. So what might this look like? We have to allocate space for the content. So what does the other side of my equal sign equal? Or what need to be? Yes, so I was hoping that someone would do Sterling again, but I'm glad you're on top of it. So we already have the length of the content available to us, so we don't actually need to malloc Sterling content. We don't actually need to do that because we already have this access to the content length. So because we have access to the content length, then, and it may not be a string. Yes, Sean, you've been ahead of me the whole time here. We are going to get to that point next. So how do we copy over the data? John has kind of already hinted to something. It may not be a string, but could I do this? Could I use string copy? And how do we know that it may not be a string? What evidence do we have to support Sean's theory? Well, what type is content? You're looking at your function right now. What type is content? Void, correct. So I didn't want to come up here just yet because I want you guys to search for this and look for this evidence. So it's the type of content is void. So what this means is that we don't know what the type is going to be. So we could use string copy and we would get lucky in the cases where we're actually dealing with strings. However, if we're getting some type of binary data, then there's going to be a problem. And so how did we handle binary data on the server? So on the server, we had this send response, right? We talked about this yesterday. It was a stretch goal, but on the server, we removed the %s format specifier, and we used a certain function here to handle binary data. There was two ways we did it. We did two sends or we did something else. Here, we're going to have to do that something else. Does anybody remember what function we're going to use to handle that binary data? It's not string copy. What is it? Memcopy, correct. So we have memcopy here that we need to use, and memcopy is going to take in a restrict destination, restrict source, and a size. Okay, so we need a destination. What's the destination? Where do we want to place the data? So this is what I'm reading here as far as the arguments. It needs this restrict destination, and then it needs a restrict source. So this is where the thing we're copying, this is where we're going to place that copy, and then this is the size of the thing we want to copy. So which is which? So what are we putting in these parentheses here? Let's start off with the first argument, our destination. What's our destination? Where do we want to put this data? Yes, correct. So this is our destination. Ultimately, this is where we want everything to go. And our source. What's that thing we're copying? And this is exactly how you could code it, where, okay, I don't remember what memcopy does, but very fortunately enough, we're getting an idea of what type of arguments we have. And so Sean says content, which is correct. And then it's saying, hey, you need one more argument here. And so what's our size? Yep, content length. And you can't stress this enough. No one's going to expect you to remember all of these things, especially if you're working a job where maybe you use 3 or 4 different languages at any given point in time. Googling or using the little hints that come up for you, very important to do. So I think more important than anything, when you are learning how to code, is figuring out how to find the answer. Not knowing all the answers, but figuring out how to solve the problem, how to answer the questions. There was I read a book about this, Henry Ford, where some type of newspaper said that he was like, he didn't know anything. They kind of slandered him in the paper and he kind of sued them. And they were kind of also bring your head against your desk trying to get a picture of the cat to show helps. It does. I guess it's the experience. If you bang your head once, hopefully you don't have to bang your head twice on that same problem later. So I think that's, in a way, it does help because you kind of write that down, or you kind of remember that one because it hurt. But there was a story I read about Henry Ford, and he was they tried to say in the paper that he was not a very smart guy, right? And so he wanted to sue them because he was like, hey, I am a smart guy. And so as he was trying to prove his case, they were asking him questions, and they just asked him a bunch of random stuff like facts, what's pi represent, or this and that. And he answered a couple of these questions, but then he got very angry about it. And he says, why would I need to even know any of this stuff when I have people who work for me that I can call on who knows the answer, and they can deliver these answers to me at any point in time. And that actually proved that he was a smart guy. That it wasn't the fact that he didn't know the stuff, but it was the fact that he knew exactly who to call on, or who to hire, or who to bring into his office to help him solve this problem. And so in business and coding, the best thing to actually know is how to solve the problem. How can I get to the answer? What resource might I use? I forget what book that was in. Maybe it was in like 48 Laws of Power. I think it was in the 48 Laws of Power book. Very good book. Um, but I like that story. I enjoyed that story because it just showed that, hey, he might not know all of that stuff, but he knew who to go to get the answers to help him solve the problems. And he accomplished much in his life, of course. So are we done here? What else do we have to do? We have to return? Yeah. Okay. We do have to return. That's a good point. I'm calling that CE. Is that it? Oh, am I? What's going on? Oh, okay. It always goes red first. It kind of freaks me out. Like, oh. So is that it? Are we done with this? Let's take a look at the cash. Let's see, a cash entry. So we have path. Actually, let me do this. I'll take this. And you could have did this in the beginning. And then you brought it over. So we can kind of use it as like a checklist. So I'll bring it down here. So we have a path, check, content type, check, content length, check. We have our content, check, and previous and next, right? So we could have did this in the beginning, and I probably should. I think I did this in the beginning for one of the functions here. We have a function where, yeah, see, I brought that over here. I didn't do it for the other one though, but for this one originally, but this is one of the techniques that I usually use so that I don't have to keep going from file to file. And then we can also do a quick checkpoint. So make sure that everything is done. So what does previous and next need to be? We didn't receive any information on them as arguments. So what do we do here? We set them to null. Correct, correct, correct. So it's a really cool way to do this. I don't normally use this, but I want to show it because I think it's pretty cool. That's pretty cool. I would normally line it out like this though. But apparently that's the equivalent of doing it all in one line. So, and we've already returned, so yes, now we are done. Cool, awesome. And this is very important to do to set this to null because we know that if we reach this null pointer as we're iterating through something, then we've reached the end of the list. So very important steps there. All right, so we have that as our checkpoint. I would delete this at this point because I don't need it in my code. I've already done my checklist. Everything is there. Probably get rid of some of that space that I used. And so what's next here? The next one we want to do is free entry. So let's free this entry. What's this going to look like? Deallocated cache entry. We kind of talked about this yesterday. The name kind of tells you what function you're going to use. So let's do it. Bam, I'm done, right? Like sweeping all your trash under a rug. Oh, okay. All right, Michael. So let me see. Free entry, content type, free entry, content, and free entry path. Boom. So is this correct? Because I already had this one, so I just add this other stuff afterwards. Will that work? It's pretty much the same as what Michael has, right? Have to free everything in the struct before the struct itself. Once you free entry, you won't be able to refer to it on the next line. Oh, man. Awesome. I'm glad you guys remember that. It's cool. So I had to bring this down like that. But wait, one thing here. Didn't we have a content length? Why didn't we have to free that? We had a content length. Why are we not freeing that? We didn't allocate any memory for that. Awesome. Yes, correct, Michael and Ian. Great. So we don't have to return anything. So our free is completely done and taken care of. So if we just have this line here to break it down, we're going to have a lot of stuff that hasn't been freed. So it may cause a memory leak. And as you guys are pointing out here, if I put this to the top and I free everything underneath it, I'm not going to have access once I free this. So that's going to have a memory leak. I might have a seg fault or some type of error as soon as I try to mention this stuff after freeing entry. So the order does matter. Now, as far as this stuff goes, the order doesn't really matter. As long as we have access to entry, we should have access to any of these points, these variables. But the actual struct itself has to be last. So good deal. Let's press forward here. And now we want to do cache create. Cache create. Where is cache create? Oh, let me do this. Cache create. All right, there we go. So this is the one where I had already showed you a technique where we can make sure we have a checklist. So that's all we're doing here. We went to the structs and we said, okay, I'm going to need these things. And I don't want to keep going back and forth. So let me get a checklist right in the area that I'm actually going to do some coding. And so at this point here, there's some things that we need to do. So what does it look like? What's the first step that I need to take as I get this cache created? Allocate memory to the cache. Awesome. But I don't know how to do that. What does it look like explicitly? I'm going to call it this. What does this other side look like? Yes, yes, awesome. That looks great. Looks really good there. And awesome. So let's do this here. So we created this here, and I have this index. So I'm going to do this right now for the index. So I'm going to talk about this more in depth. But I know this is going to be some type of hash table or something, right? And so let's move on to the next one. Head and tail. What does this need to be? Because I didn't receive that as argument. So what should this be? Knowing what I know about the double linked list, what should it be in the beginning, initialized to? The head and tail. This is where we are here. And it's giving me this hint that it's a double linked list. So this should give me a hint of how we should initialize it. It's going to be a lot like our previous and next in the cache entry, right? Which means we have to initialize this to no, correct. Well, now I have this max size. So how do I initialize this to the max size? I see that I'm getting a max size here. Integer. So this would be similar to our content length, right? And again, because it's an integer, I don't have to allocate any space. Now there is another problem that we're coming into. And it's sort of a problem because we didn't receive an argument for this. But we do have a friendly comment here. Current number of entries. So in the beginning, how many entries do we have? Zero, exactly. Cool, cool, cool. And then of course we need to do one final thing where we're going to return cache. So let's dip into the hash table here. So our index is going to be a struct hash table. So this is where we would probably want to go and do some inventory on that hash table. We've looked at it before, but we've never had to call it until now. I think we looked at it in the beginning when we first skimmed through the repo. Now we actually need to call this thing. So I would probably start here and see what's available to me. So I can see hash table structs, boom, 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 okay. And then I will take a look at this. So immediately if you're looking at this and you don't see any of this down here, you're thinking, oh, I'm gonna have to build out this struct. But then if we start to look and see hash table create right there at the top, okay, there's a thing that's going to create this for me. And I think we talked about the hash table and the fact that it was already done for us. So let's take a look. So we should be able to reference this function as long as we have something that points to our hash table. So this is where we'll have to probably take a look. And someone's already included this for me. So that's pretty neat. That's not always going to be the case. So you may have to include this yourself. But we know we have the thing we need. So now we can reference this function here. So we take a look at this, and it's looking for a size, and then it's looking for whatever this is. What is this? What is that part of the code? What type of argument is that? So 2 ints, not exactly 2 ints. It's going to accept these ints. This is actually a argument that says I'm going to accept a function. This is what it looks like when I want to accept a function. And the function should return an integer. And this is my function name. And then these parentheses here is the call of my function. And these are the arguments for that function. So it looks really, really weird, of course. So I probably want to do some more in depth. I remember that, hey, when I skimmed through this, a lot of that stuff was already done for me. So how can we use that? So we have an example: create a hash of 128 elements and use the default hash function. And so struct table ht is going to return the hash table create 128. That's the size, and null. So by using null, I can use the default hash function. I don't have to put some function in there. And so at this point, I'm probably want to go with that because, to be honest with you, I've been doing this as a student. I've been kind of doing these lectures, and this still looks weird to me. I know that this is a function, but it does still look weird to me. It's just like, functions don't look like that in any other language. So it definitely kind of make your eyes water a little bit. It's intimidating to see this. Just what is this exactly asking me to do? But if we do a little research, we can then discover that we can just put null in here, and it's going to allow us to use the default function. I may even go even further and take a look at the create. Where is it? Where is this create function? Hash table. Maybe I went too far. Oh, there we go. Hash table create. And I can see that same little function arguments, but then I'm also seeing that if hash f here equals null, then hash f equals default hash f. So what is default hash f? Oh, wow. This is the function. So now I can gain understanding of exactly what that argument that's over here, this is exactly what this is. This is what this thing is. So I'm going to come down here. I'm going to do this. So this is the name. This is the return type. We see a void pointer. And then we see ints. So this is exactly what that's looking for. So a little research in the repo, and we get major help. And then also, we don't actually have to have our own function or to create our own function. We can just use null, and it's going to use this function, which should work perfectly fine for what we needed to do. So whenever there's a thing that does what we needed to do, let's just use that thing. So let's come back here, and if I have to take a look at this in depth, I'm going to take this. I'm just going to grab this as my I'll make sure I didn't change anything. I think I just added the comment though. Yeah, cool. And so now I can come back over here and I can say, all right, so I know this is null. This is my hash function, and null allows me to use the default hash function. So now I just have to change the 128. And what am I going to put in here instead of 128? Hash size. Correct. Just give me a semicolon at the end there. And we're returning, and so we should be good at this point. So I can do my quick check. I can see index, see my head and tail, see my max size, see my current size. So I'm checked off. I'm returning. I don't have any red squigglies. I'm good. I can get rid of this now. And we're off. So that is the three functions that we're going to cover today. Is the solution, allocate entry, free entry, cache, create. What I will do is I will post this in the channel, first of all. So we just covered this. If you did not implement this, I don't want you to continue to bang your head on this. You've already done that yesterday. At least you should have done that yesterday at the very least, and tried to muscle over how to solve the problem. And so now at this point, we want you to move forward with the code. And then now we're going to try to tackle something new. But we're going to try to use the techniques that we use to create this in the next couple of functions that we have to do. And as well, I'm not sure if everybody knows, there are cache tests. We don't have enough done currently to pass the test, but there are cache tests. So we can run the test files on our cache once we have that completed. But let me share this right now. And cool. So what we'll do now is we'll take a 5-minute break, and then we'll open the floor for questions. Maybe you have a question on how to implement one of the functions that you have today. Maybe we can go over the pseudocode if you don't understand what it's saying. But we'll open the floor for questions. And so let's take a 5-minute break. Let's be back at the 10-minute of the hour break time. All right, welcome back. We should be back. We should be back. So at this point, I'd like to open up for questions. Um, Maybe you're trying to follow along now, but you have some type of bug, or maybe you move forward and you have some type of bug or question. Okay, so let me share my screen again and go back to this part of the code, the README. And so cache put we didn't go over, cache get we didn't go over, and then of course adding the functionality to our server we haven't gone over. But once you get your cache implemented, the cache put and get, you should be able to run tests. So that's something that you could do. One thing you could do when you create is you could probably add that to your main and just do some printouts to make sure that the cache was actually implemented. So you could test that out that way. But your cache should be up and running before you get to the step 3 for the cache, which you would add functionality to server.c. But looking over these steps, does anybody have any questions or something that doesn't make sense? No questions. Don't be shy. I talked about. I posted yesterday that I still get nervous just before, like when I'm doing it. I'm totally fine. It's kind of like when you play a game when you're getting ready for the game. And I wrestled in high school, ran track, stuff like that, played football. But when you're getting ready for the game, you get nervous. And then once the whistle blows, it's just like it all goes away. And so I thought that by doing these lectures that I wouldn't get nervous anymore, but I still get nervous like 15 minutes before the lecture. But for me, my approach to that is this is similar to being in a job interview, and I want to sound great. So I just practice. I go over the things that we're going to talk about, and through experience, maybe I won't be nervous. But it's surprisingly, I still get nervous like 15 minutes before it, and then this and that. But if you feel like some type of way about asking questions in front of everybody, just do it. That feeling will go away, and it will actually be pleased. This will say to your boss that, hey, before this person implements something, he definitely gets the details. That's better than the person that just implements something, didn't get any details, and now we have to redo that thing that they did. So, uh, feeling some type of anxiety about being in front of the group or asking a question, the only way that's going to eventually go away is through practice and just continue to go forward. So, cool, no questions. All right. Well, this one thing that they want me to talk about is some of the stretch stuff, and explicitly they want me to talk about expire cache entries. So it doesn't make sense to cache things forever. What if the file changes on the disk? Add a created at stamped cache entries. The item is found in the cache. Check to see if it's more than 1 minute old. If it is, delete it from the cache, then load the new one from disk as if it were found. You'll have to add a cache delete function to your cache code that does the work of actually removing entries that are too old from the cache. Okay, so let's talk about this here. As I look at these steps here, what's one of the first things that I may have to do to implement this stretch goal? Well, it's actually telling me exactly what I have to do. So what does it mean when it says added created at timestamp to cache entries? What does this part mean? How might I do that, and where do I have to do that at? What is cache entries? What type is that? In the structure. Correct. Correct. So what they're saying here is that inside of this struct, we need to go and add a timestamp. And so, not this struct, but in here. So if we just do things here, it's not going to work. So we have to actually modify the header file. And we have to come in here and add a timestamp. So we can use time t timestamp like so, and that's going to work. And so what this actually is number of seconds. It's an integer, and it represents the number of seconds since January 1970, which is pretty much when Linux existed. So that's like Linux time. So since January 1970, it's going to give us the seconds. So it's a pretty good way. And then there's plenty of ways to convert it to find out exactly what date it is. But so that's our timestamp that we would add. So of course, what's the next step now that I've added this timestamp? Correct. So that is the question we would ask. Is there anywhere else that timestamp? Oh, you're asking, is there anywhere else that timestamp could go? I am not sure exactly what you mean. It should go into our entry struct. So we want to keep track of when we add things. So, but I actually like your question. So to come to the next step of that I have to make is where do we need to update this now? So looking at your question, and I guess how I looked at it first was now I have to come back over here to my cache creates or my allocate entry. I have to come to my allocate entry now, and I have to allocate that position. I haven't, or maybe I have to, actually, do I have to allocate space for that? I'm going to have to check that one out. So let's go C programming. And what are we using? Time H. Time T. So I'm going to have to reference this to see exactly what's going to be needed for this. Time T in seconds, time null. So if I use time null, it's going to tell me the exact number of seconds since January. So this is going to give me my timestamp here using time null. Just roughly reading this. So, and then it's also an integer. So it's not going to actually require me to allocate any space. So great. So at this point here, I may have to add the timestamp in here as an argument. Perhaps I would also have to go and update the create. So when we create, we're going to create this timestamp here, or no, this is cache create. This is not the entry. allocate entry, right? Yeah, so allocate entry should take care of it. We're going to set this up where we take care of our entry. So we didn't call it create entry, we just say allocate entry, which is pretty much the creation here. So we're getting all of this stuff and we're going to set it up. So I might not need an argument. So what I could do is just do something like this, CE, and then now I could say, I don't see it in here. Timestamp. Okay, let me go back to that file. What library do I need? Okay, there we go. I probably should have this up top, but I don't know if the order matters. But now I can get rid of that message that I had there, right? And now I want to see timestamp. There we go. Equals time. No. So I don't actually need an argument if I just use it how the instructions said to use it. So I won't need an argument, but now I can set it to the timestamp. So that's going to give me the timestamp right when we create this thing. And so now it's there. But I really like that question because now we're going to go see where we have to update it because it's not just in one place. So from here, where is that? There's one more thing that I want. Oh, there it is. There it is. The time, no. Cool. So let's go to the server, and then I'll let you guys go. I wanted to just show this. So we go to our create file, and of course we're going to have to update this a little bit, but I just want to show what this would look like. And maybe I do it up here. And so we're going to kind of check our timestamp where I believe the instructions said if an item is found in the cache, check to see if it's more than 1 minute old. Okay. So what does this code look like? So we're going to pretty much do something like an if statement where we're going to say like if, let's see, we have, what do we have access to? We have access to the cache, but we'll need to get to that cache entry. So I won't do that part of it, but let's say we have CE as our cache entry. And so we say timestamp greater than the current time. So we'll do something like, and you may have to import time inside of your server to have access to this. And so the current time, so you want to say this current time plus 60. So this will be 60 seconds. And so you're trying to see if this is a CLO event greater than a minute. And so if it is, so if the timestamp is expired, so if it's greater than a minute, that means it's expired. So we want to delete from cache and load from disk. And so that's what they're talking about when they talk about this particular function that you're going to have to develop or create. What's going on with that? All right, cool. So they're saying you'll have to add a cache delete function to your cache code that does the work of actually removing entries that are too old from the cache. So that's what they're saying there. If it's too old, we're going to delete it from the cache, and then we're going to load from the disk. There's other ways that we can go about things where you don't have to implement it in your code, or maybe you want to tackle that, but we can compare by using operating system operations. We can compare if the file has been modified. So if the file has been modified from this, which this would be much slower, but if the file has been modified from disk, then it doesn't matter if it's expired. We want to load from this because this is going to have something different. And so we talked about this yesterday, where you're on this website and it usually has you logged in, but for some reason today it logs you out. So it's making you log back in to get this fresh stuff. And so instead of reading from memory to see, okay, this person's logged in like normal. And so that's one way to do it, but it's a little slower if you do it that way. But it's pretty efficient in the sense that if there's a modification to that thing that we're searching for, we should always get the newest update. But that involves using your operating system a little bit, because you have to check to see if the timestamp. So when you're on a file, when you have these files, there's a timestamp of the last time you modified something, right? So let's see. Let's go to documents. Right, so we look at this here, date modified. So we have to use some type of operating system functions to actually get these figures here. And if that has been modified, so if we have like this earlier date, for example, I put it in the cache right now, and then when I go to use it again, I have a newer dates or earlier dates. Like for example, right now it's 12:27. If I go to check the cache in 5 minutes and I see that this has been modified at 12:30 and it's now 12:32, then I say, okay, I want to load this from the disk instead of the cache because there's been a change. And so that's more complex, but something to kind of consider if that's something you want to stretch to. But other than that, I don't have much more than this. Wanted to talk about the timestamp entries, and I will allow for any questions here before we go. But other than that, that is all we have for today. Cool. I will let you go. Enjoy the rest of the day. Reach out if you need any help, and have fun with labs if you're doing labs. If you're not doing labs, I wish you the best of luck on your job search. And hopefully Lambda School has been everything that you intended it for it to be, and everything works out how you want it to work out. So I wish you the best of luck. I look forward to having a drink on your behalf when I read your you in the higher channel getting that first offer, or maybe a few offers in that job you accept. So you guys enjoy. Have a great one. It's been fun.